Hello, everybody, and welcome to our webinar today. We're absolutely delighted to be joined by Boston Scientific, by Yixin Wang, who's been doing some really fascinating work that she's going to be talking to us about. But before I hand over to her, I'm just going to go into our housekeeping rules. For those of you who haven't been on one of these webinars before, this will be new. So what we're going to do is we're going to put you all on mute, so we haven't got any extraneous noise going on whilst the conversation is happening. But if you want to talk at all, if you want to discuss with Yixin or ask her any questions, then please do use the chat panel, which is on the bottom right-hand side of your screen. So just post a question in there, and we'll pick that up at the end of the presentation. The recording afterwards will be available on simulatehealthcare.com, and we'll be sending you an email to let you know that it's available. And I think that's probably all I need to say on that. So, with that, I'm going to hand over to Yixin and say thank you very, very much indeed for agreeing to speak to us today. I'm really looking forward to hearing what you're saying.
Hi everyone, this is Yixin. I just want to make sure you guys can see my slide.
Yep, we can see it. Thank you.
Okay, good morning, good afternoon, depends on where you are. I am Yixin. Thank you, Claire, for a nice introduction of me. And I was the program lead for this engagement. Just want to take you through what we will talk about today. We'll start with project overview so you can understand what kind of customer we had, what problem we had, and I'll take you through the sample of simulation and some key results, and then we end up with a couple of slides summary of lesson learned, and we open up for question and answers. So I would like to take all the questions at the end, if that's okay, because there's quite a few slides for me to go through, and as you know, simulate can be complex simulation at times, so we'll go through a lot of details. So let's take questions at the end. Let me first tell you a little bit about our customer. This customer is based in Toronto, Canada. It's a heart center. I'm trying to use a language that if you're not in the healthcare, you're familiar with. But basically, just think as a heart center, and they do all type of heart procedures. They treat about 55,000 patients per year. They're quite progressive. You can see they do a lot of international clinical trials. They also partner with some top hospitals in the world, such as Mayo, to looking at more advanced technologies and skills in treating patients. They have a pioneer program, kind of like Dragon's Den for Innovation Committee. So I guess the takeaway here is we had a very highly motivated customer. They're very engaged, and as well as their physicians, they're very open for us to show them the simulate and the simulation model, what the benefit could bring to the program I was leading. So a little bit about our project background. For those of you who are not familiar with procedure rooms in the heart hospital, we call it Cath Lab, catheterization lab. The Cath Lab is short for that. This place has 4 labs, thinking different procedures in different labs because of the equipment. So Cath Lab is normally examination in the hospital clinic with diagnostic imaging equipment. So some of them can't really cross over. So each type of procedure would have their own specialty room. So this customer had 4 labs to start. They had 2 PCI rooms. PCI are the easier procedures, mostly angioplastic or stents, if you are familiar with that. And they have 1 structural heart procedure, and they also have 1 EP lab, which is electrophysiology procedures. They had 14 prep and recovery bay beds, which were located right outside their Cath Lab. They had a very strict operating hours. In the bay, they start at 7 a.m. and finish at 6 p.m. In the lab, It starts 8 a.m. and finish at 5:30. These are quite different if you're based in the U.S. and the U.S. system. Cath Lab tend to work a little bit longer, but this Canadian customer had a very strict cutoff time. We can talk a little bit more about that. Some other important input I think you should understand upfront is the resource ratio. They operated at somewhat expensive level, and they used to have all nurses in the room. In non-congenital labs, they have 3 nurses to 1 patient ratio. Congenital structural heart cases, which were normally more complex, so they had 4 nurses. So somehow it's pretty expensive model compared to the U.S. model. You would only have normally 1 nurses and 3 techs in the room. So part of, in the middle of all this simulation project, we did suggest to look at adding in MRT, the technician role. So they were actually working on that. Now they've added 4 technician role in their lab space to support each of the rooms, and they have limited patient care restrictions, such as they couldn't admin meds, but they could do a lot of equipment setup for the room. So let's move on to the next slide. Now we understand the basic of the project. Here, I'd like to show you an overview process of our program. So it's Boston Scientific team had performed end-to-end process evaluation. A lot of aspects have been considered into this diagnostic phase. So simulation was part of it. The simulation model we're going to talk about, the scope is really from patient admission, which you can see from here, to patient discharge. Like any other cath lab, the patient flow is very similar. Patient can enter the cath lab directly or coming from a ward or inpatient unit, get prepped for procedures and wait at the same area, and then go through the cath lab recovery. Depends on the patient type. It may be directly discharged or transferred into a ward for recovery. So in this specific hospital, there were 3 types of patients. Elective patients whose procedure was scheduled in advance. There were urgent patients. Patients come from the inpatient unit or the ward with urgent need, but not always performed the same day. And lastly, there were STEMI, which are emergent patients that come in from ambulance that skip all the process, go straight to the lab. Now we all have a good understanding of the current state. Let's take a look at the simulation-based scenario analysis. If you have been working with Simulate previously, you know the importance of asking the right questions. So this slide really just want to show you a list of questions we heard from the leadership and the frontline staff. And to summarize, first set of questions we received were, what's our team's current performance, typically from leadership? They want to understand, can you tell us the average utilization among all labs? Do I have any capacity left to add a new business? Which procedure is the busiest? Which one is under or overutilized? Management seeks a good understanding of utilization in order to expand certain markets. In this customer, they were talking about expand their pacemakers, structure heart program, as well as keep the urgent type of stents, the PCI patients, in order to manage the length of stay expectation from higher up. Based on the baseline performance, we ended up presenting 12 scenarios. I'll go through it briefly, but I'll take 2 scenarios, take you through the details. The 12 scenarios were made to improve utilization by adjust physician schedules and lab and bay operating schedules. So key takeaway here is, really during the partnership process with Simulate, the leadership team was also got better understanding at what kind of questions they should ask their scope became narrower and more specific, more focused, rather than asking a very broad question. A lot of you probably would hear as, what should we do? Where are we at? Are we doing all right? It's a lot of questions we get, but during this process, I've really learned how to ask key smart questions per se. So moving on to simulation design, there were a few key variables that simulate required for building a model that we need. One, the top one is demand, really to understand the current and projected demand in the lab, also the business needs. And there were a lot of work there trying to align leadership team and get a good understanding on that. Secondly, schedule. And there were quite a different type of schedules involved in this model. They had lab schedule, patient schedule, and also physician schedule. So thinking like a manufacturing, there's machine schedule, you have builder schedule, you have management schedule, you have supply chain material schedule. Same as in the lab. The most complex one could be the physician schedule, because you have to look at some physician does training in different places. They teaches in college, they travel, they do all different things. So their lab time is very precious. Thirdly, they simulate needed information for day of patient process, which is really the process I took you through at the beginning to understand the operating process and walk the patient's flow. Finally, resource constructions were a big input for this simulation design. So I include some examples in the next slide. These were the details. We looked into each variable when we're building the model. For example, in process details, I talk about, you really have to walk the patient flow. You have to understand who performed the activities and how long they take and where the activities was performed. So all these should really come out from your process walk. And if you talk about demand, I talked a little bit already about the physician demand, but patient demand, you have to understand the daily patient schedule, the type of procedure, the level of patient demand by different type of procedure. So how long each procedure takes, how long it takes them to recover, that's all considered into patient demand. Resource constraints is really to understand which clinical staff perform which procedure type and which steps. These are all staff involved in the operation. How many shifts are there, and do we have hard staff, percentage of time each staff member spends on non-patient touch activities. So let's take a look at the final model. I like to pass control back to simulate so they can run a model while I talk through that. So this is the final model you're showing on the screen. It's the layout. The layout is at the actual hospital layout they provided to us. So on the left-hand side, you'll see a couple of blue boxes. That is where the key variables were embedded into, and you can modify it anytime. So let's maybe click open one of them. So you can see the some of the parameters I talk about here. You can see the schedule, the lab mix, the operating hours, and maybe just open the schedule. So in the schedule, you can see what type of cases scheduled in each room and on which day. So anyway, I just want to give you a sense of how this model runs. On the top hand side, you can see a clock. This represents the length of the simulation you want it to run. So the nice thing about simulated allows you to simulate scenarios for a day, a week, even up to a year in a few minutes. So Steve is running this, and you can see the little dot going through it is actually the patient. So here you can see the bay bed I talk about. They should be like 14 of them. They were the original layout. And on the bottom of this drawing, you could see the 4 procedure labs. Steve, do you mind to point those out? Yes. So there's the Cath Lab 1, 2, 3, 4. And on the right-hand side, these spaces where they are thinking about merging 2 other Cath Labs from a different location. So like I said, this graphic was done based on the layout map hospital provided to us. So the model is basically embedded into the actual design of the physical space. This was a really nice feature for us to present to our customers. They liked it they quite liked it because they can see and feel how the process was running. Especially for physicians, they were really excited for us to showing them this simulation. Okay, so do you mind me to take back the control, please? Okay, so just check you guys can still see my slides.
Yes, yeah.
Okay, so perfect. So let's take a look at some of the key results that model generated. Patient delays, schedule backlog. Actually, patient delays, you could see the data that was running on the simulation. And if you're running it very long, if you stare at it, you could see some places, stack up where represents the bottlenecks in our process. Another key result was schedule or slot utilization, resource utilization, room and the bay occupancy. So like I mentioned earlier, we generated 12 different scenarios for this project. 12 of them were categorized into 4 key themes. One is, understand the base case, the current state. Don't focus on growth. One of the leaders in the leadership team said, let's just understand what we can do to enhance the current performance. So a lot of variables are the same, such as demand level. Demand level would be changed, but the number of labs, the lab mix, the day hours, a lot of basic operating things are the same. Second theme was looking at additional specialty volume growth. Some physicians on the leadership team were specifically taking care of their business needs, right? They still need, even though it's a heart hospital, they still need to look at how many patients are waiting outside their door and can we take more certain of specialty, certain disease on the horizon. They need to make sure they can adapt into the change. The third team is transfer of some OR-based cases. They had currently a couple of cases that they're doing daily, weekly basis in their OR space, and they would like to take it back because there's a long walk for their staff over there. It's harder for management to manage or negotiate with the OR. Finally, they're looking at, merge 2 sites into one, which is the biggest reason we started this project is to looking at expand on already locked down physical place to expand from 4 labs to 6 labs. Since we don't have a lot of time to look into each scenario, I have handpicked 2 as example to show you here in the next slide. So 2 scenarios I want to show. One is scenario 5. You can see the number on the left side, 5 and 10. Scenario 10 is random pick. Scenario 5 happened to be the best scenario based on leadership agreement and performances. So you can see the demand level is the same. It's their hospital system funded level plus 2% unfunded level, services that they observed, and plus the pacemaker from OR. The lab mix is the same. The number of labs is the same. Lab mix is different, where scenario 10 would actually allow more expansion. Lab hours change. Scenario 10 it's moved away from the hard stop at 6 o'clock, and reschedule cutoff cancellation policy here is quite different. One is cut off at 4:30, One is cut off at 7. This cutoff means, if I have a patient showed up at 5 o'clock, we will not take them even though the bay has space, the lab has another hour to go, even though it's a 30-minute procedure, because their cancellation policy stated they cut off at 4:30 to ensure that everybody would finish work by 6. So obviously it's one of their restrict for this project. So you can see the result. The result, you can probably guess the result were quite different. Scenario 10 would have generated even better results and eliminated the wait list. However, leadership team has decided not to be that aggressive, and they want to implement scenario 5 first to realize some quick results. So by doing scenario 5, you can see that it's designed to accommodate the entire requested volume, and adding some more from OR, and the overall performance would bring their room utilization to a higher level. Slot utilization definitely higher level, some around over 70%. We can add 6 more slots in pacemaker space to adapt into their business needs. Seal was able to add 2 congenital cases per week, which is a big news for them, because in Canada, if you're in the field, the congenital cases are done in 2 heart centers. One of them is our customer, the other one is based in Vancouver. So there's a huge demand, but there's only a few physicians can do it. So the center want to be able to, adapt into the patient needs out there. We were able to redesign the schedule based on the best estimation, and so there were a lot of improvement projects coming out of this scenario, even though it wasn't led or partnered with Simulate, but the simulation was able to provide us that idea up front. So just to recover what we talked about earlier, to summarize the area of improvements from simulation are really looking at the scheduling template, which was a template they were operating for the last 15 years. The reason being, I mentioned slightly earlier about physician schedule. The physician time in the lab is very sacred, and it's a time you cannot touch, and nobody would want to touch, because everybody hold on to their most valuable time in the lab, which in turn make operation very difficult, because running Cath Lab is one of the most expensive item for the management. So you want the lab to run efficiently. You don't want a lab has any idle time. And secondly, hours of operation. You may get the feeling that I kept talking about this hard cutoff line. This is the one thing we realized through our diagnostic is even though they have very engaged staff, very experienced staff, very little turnover, but the staff, especially frontline staff, are definitely not shy of requesting for hard stop. Hard stop make a lot of stuff very difficult if you cut off at 4:30. You can't adapt into any change or add-on cases that would drive the decreased satisfaction for patients. Number of rooms and bay, I'll talk a little bit more around this. One of the question was, if we're going to move to 6 rooms, how many more beds I can add? But looking at the physical place, it's a pretty old building, and there's only so many we can add. So we want to understand the capacity in the bay there. Some are the busy times. Sometimes maybe we should bring in more chairs instead of beds, and these are the questions. I'll explain that a little bit better in one of the later slides. Overnight stays is another one. Do we want to open up the bay and to overnight so we can care for those patients that are coming out at the end of the day and make sure they recover well before we send them home? Cancellation policy, same as linked to hours of operation. Demand levels, I already talked a little bit about that. Every person on the management team might have a different expectation for expectation for their business model. So a lot of work aligns all of them together. So another nice feature of Simulate is the ability to build very pretty charts and reports for repeatedly use. I know that's important for many of us here. For example, we had 12 scenarios. All of them generate tons of graphs, but we had a set of standard report built up in Simulate. So all of them produce the same chart, you know, and present the numbers in the same way as we want, which helped us to build presentation in a very efficient way. Let's take a look at some of the results. What I'm showing you here is just a highlight. I just took a couple of slides literally from the entire package, and there are too many charts to show in an hour. So the first one you'll see is a sample of slot utilization by type result. So here, this slide was used to help leadership understand their current performance, look at the procedures that is overutilized, and the ones potentially can donate some case time to others. Understanding this was a big cultural shift or cultural challenge for this organization specifically. You know, they're trying to do a lot of more Six Sigma type of projects. They're trying to embark on change. Luckily, they have very engaged physician group, and they hired a new chief MD, so they who are from the U.S. healthcare system. So he was very aggressive and trying to understand, you know, where are the potentials. So after this, you know, this is after we finished with the Simulate engagement, we actually completed a project that specifically looked at physician schedule. We changed their template from the last 15 years and was able to work out some solution to level load, lab hours, you know, and have some sort of plan B process if patient doesn't turn out what's going to happen. So we were able to make sure the lab is running a back-to-back kind of fashion and no idle time. Second slide I want to show you is the result from the Bay capacity section. I mentioned earlier Bay and bed, number of Bay and bed. So this chart represented opportunity and challenges in the Bay Area, especially after adding the 2 more rooms from the other center. So with the expansion, Bay will have a bigger space, not that much big, but the CVSL, the cardiovascular service line administration kept asking us how many beds do you think we need? How many beds we can adapt business growth? So here is what we were able to give to them. You know, for example, you can see that let's say if you run unconstrained, the simulation shows that we could expect the need up to 28 days if all 6 rooms are experiencing peak demand at the same time. But then again, occupancy drops quickly by the day, so there may be opportunity to reduce construction costs by recognizing the schedule. So the schedule would be the lab schedule we talk about, not the physician schedule. So, you know, one thing maybe I should mention is you touch one schedule, all the schedules need to be considered. So one thing here is we actually also did another project trying to level over the Bay Area a little bit and think outside the box type of thing, you know, not just having all the beds, but instead of, you know, recovery seats, depends on the procedure you need. Last slide on results is an example of how we came up with some improvement ideas, how we compare results from scenarios. So for example, you can see we use combined demand with the current hours, increased demand with current hours, or increased demand with extended hours, and trying to kind of put everything together and draft a nice story to tell to the leadership team, because a lot of them are kind of far away from operation, and if you're showing them all your 12 scenarios data, I'm pretty sure they would be lost. So another key takeaway is working with Simulate can help you to come up with a nice story, explain to the leadership what you're trying to get out. So this was also, I should mention, this was also a big win for physician team. for many of you who work with physicians know that they like numbers and charts and they like comparisons. They like you to give them option in a very short time. So this was a nice feature that we were able to use from Simulate. So then let's take a look at recommendations. Again, these are just slides I taken out from the package. Just want to show you what kind of reports we can come out from this simulation model. This answers the question of, if you think back what I spoke of asking the question, the first one is understanding my current performance. So this slide was really looking at the baseline, help them to understand where each lab is at. So on the right-hand side, you can see that one lab is running about 93%, and you can see the difference between the cleaning hours and procedure hours, and some labs running 45%. You can compare that easily. And also slot utilization, which is very nice. A lot of you working this space know we could probably do this in Excel too, but it would be very time consuming. I think Simulate was able to have this dynamic aspect of process, which I really liked and enjoyed to work with. Not just looking at the data on Excel sheet and you can play with the number on Excel, but also looking at run it in the simulate. The simulation can give you more range of data if you like. You can run a week, a month, a year of answers for that. Again, the next slide showing you the summary schedule template. This was the one I talked about. We were able to working on some schedule change and end up added 6 pacemaker slots per week and 2 congenital structure heart procedures per week, and took away slots from elective PCI, which had too many idle time. Physicians just hold on to the slot for the sake of it because they now they lost the time. They have to fight it back, and that means they have to be way more productive as they're used to. So this information was the input to an improvement workshop, a Kaizen workshop we had outside afterwards. Lastly, a slide on room utilization. Understand the slot and room utilization before versus after. Nothing very special here, but just want to show you that scenario 5 actually be able to increase the room utilization for 1, 2, 3 of their rooms mostly. So I want to wrap up my presentation with a couple of lessons learned. I think, again, I mentioned this quite a few times. Our client was really enjoying the dynamic view of the final product, and so was I. And I came from engineering perspective. Then later on, when I did a lot of starting, we know the importance to have that dynamic view, and you can show things quickly. What's going to happen the next year. Ask the right questions. Like I said, it's a learning curve for clients to ask the right questions and not become a bigger scope. So I think they learned a lot from this engagement tool. Understand the variables. What's in your process, not just walk it, but also aligning frontline staff with leadership staff. That's quite important. Work and see the process as always. Well, any process improvements, and go see it and collect the frontline staff voice of the customer, voice of the hospital. Managing the scope closely, more from a PM perspective. The simulate can get quite complex if you don't manage your scope strictly throughout. Understand data results and need to have a good story to link between the data and simulate model is another learning that if you just go with simulate model and show them stuff, and they will just look at you go, what you supposed to say, right? Because they're not used to process-wise and or working with data. So for the ones who are actually hands-on with simulate and the regular use of the I feel like not on a daily basis, but a weekly or perhaps every bi-weekly basis. Otherwise, I lose a lot of things I learned with simulate, and it's not like very straightforward like any other software package. So you just have to make sure you up your skill set all the time. Again, finally, I want to wrap up with an important thought for process improvement is the plan, do, check, adjust process. Same for simulate. You build up your model, you confirm with the number and if something doesn't work out, you go back. You can change it, adapt it, which is the best feature of simulate is you can change things quickly, right? You can run your simulation quickly, and it's risk-free. If you fail, it's still risk-free. So that concludes my presentation for this project, and I hope you enjoyed my slides and the talk, and I would like to open up for questions if there are any.
It seems to be a very rich project, which people have got a lot out of as you've gone through it. And I wondered if you could say something about the number of iterations that you went through, because I know you were keen to keep to the scope of the project, but I think as you showed the client the results, then you probably did go through a few iterations as they asked further questions and they got deeper into the process. Can you say something about that?
Yeah, so we ended up with 12 scenarios, but when we started, I think myself actually generated 45 scenarios.
Whoa!
So I think at the point that became too time-consuming to go through every single detail while we tweaked through the process. So Brittany back then, who's from the simulate, and helped me on this and gave me a lot of guidance. Think through, what's the point change this if you're not change the other one, because all the variables are linked together. So we end up with 12 scenarios, but just want to give you an idea of how big the scope was, or how big how much work was it behind it to narrow down to 12 scenarios.
That's really interesting, and it sounds as if that some of the lessons learned, some of the results actually were all about the improvement of the labs as they currently are. Although the initial question was around potentially merging some labs, actually some of the improvements were linked to the existing process. Is that right?
That's correct. I think there are some considerations here is, they know 2018 they're going to have 6 labs. So they have to be ready for that. But I understand their current state, they've learned a lot about themselves, right? And we don't know what we don't know unless we show them the numbers, to show them comparisons with other Cath Labs or other country, right? So this was helping them to understand the current performance, helped us to think about what we could do to improve in the short term, so they're ready for that expansion. But when we started, the emergent question was how many tests, because the construction, while we're doing all this, construction is happening in Thailand. So they have to make some decisions and what type of labs, would be the most benefit to us. But we can't really answer anything without understanding the current state. So we answered the questions, but give them a lot more than what they need. But of course, that's through an engagement with Boston Scientific and Simulate. Simulate is kind of like help us open the door, I guess, with all the improvement projects.
Thank you. And I mean, having had that experience and getting that value from it, would you reuse that model, do you think, with another client, or would you approach the project in the same way? What would you do differently?
I think I would reuse the model. In fact, I'm trying to see if there's a way we can reuse the model. It would be very helpful if they make a standard setting, now I can sit down, write down a list of questions I want to ask, a list of variables that I need to try different things, right? A list of them which should be locked down from start. So I think I would I would spend less of time with the client to generate even better results if I reuse the model. So for sure, I'm thinking about reuse the model going forward, but it's not just really fixated on Cath Lab, right? And if you work in other clinic, let's say it's a outpatient clinic or a walk-in clinic, you can still using the same thing, and the thought process is the same. The model building skills is probably the same. So definitely learned a lot with this project.
Thank you very much. That's it's so insightful, I think, and really appreciate your time and your slides and taking us through what you've got from this project. And I think a lot of people, I mean, this is a common question, and I think a lot of people will have got a huge amount from that. So I wanted to say thank you very much indeed, Yixin. And to everybody on the webinar, thank you so much for listening. We will be emailing a link to this, and if you want to ask questions afterwards, I'm sure we can facilitate that as well. So Yixin, thank you again. Really appreciate your time. Thank you, everybody, and we look forward to talking to you the next time we put on one of these webinars. Bye, everyone. Thank you.